Venkat Subramaniam onto the stage, who will talk to us about keeping things simple. And you'll notice Venkat has chosen specifically to be exceptionally comfortable on that stage and keeping things simple. Thank you, Venkat.
I am very comfortable, thank you. It's a great pleasure to be here. I want to talk to you about something we deal with every single day of our lives as developers. I want to talk about complexity and how we can possibly keep those complexities off and work towards simplicity. So what I want to do today is to rethink about the lives we live in terms of fighting that complexity. And as a consultant, I go and work with a lot of different organizations. And one of the things I very quickly find out is how a lot of us have dragged ourselves into very highly complex situations. So much so, it becomes incredibly difficult to get out of it as time goes on. So one of the things I would experience is to start recognizing when we are making things complex and to take the turn so that we can move towards simplicity. Well, let's talk about complexity for just a little bit. In this room, we have probably what is the most capable system ever. That is the brain each one of us have. And brain is extremely capable. We are very creative. A lot of times we look at our fellow developers and ask them, how did you even think about this? And what is really perplexing is that exact same thing that's so creative, so talented, is also the very same brain that gets tangled up into emotions and analysis paralysis and blocks our thinking as well. And a lot of times we are working against ourselves, and we need to really step back and break out of the complexity and the line of thought that has led us into it. So from that point of view, one of the things I often spend my time with at home is talk to my children about various interesting facts. And one of them is they very early on in their life learned about Schrodinger's cat. And the question is the Schrodinger's cat alive or dead? And this is a question, and I kind of think of this quite a bit. A lot of situations in life is like the Schrodinger's cat. We're not quite sure about its state at that particular point. But I want to talk about complexity here today. And as Confucius says, life is really simple, but we insist on making it complicated. So I want to start with the question, why? Why do we make things really complex? And I'm going to say a few reasons why we are making things complex. The first reason why we make things complex, honestly, is it feels really good. And let's be honest about it, right? It feels really good. You are creating something, you show it to your colleague looks at it and says, oh, that's simple. You feel a little let down. You say, give it back to me, I'll bring it back tomorrow. And then you take it the next day and your colleague is scratching head and saying, gosh, I'm trying to figure out what it's doing. And we beam with pride. It's like, yeah, that was worth the effort. And it makes us feel really good. When you make something really complex, other people think that we are actually worth something. So there's a credibility, unfortunately, associated with it. And there's yet another reason why we make things complex. Complexity leads to job security. When it comes time to lay off, they say, whatever you do, don't touch Joe, because no one has a clue what he's working on. And so that's a really good security as well. This is one of the reasons why I love interns from university. When they come and work with you in the summer and they go back to campus, follow them and see what they tell their colleagues. They will tell them, the company I work for, those people are geniuses. I understood nothing of what they do. So we tend to really build this complexity over time, and then we unfortunately begin to take pride in it, which is really dangerous. So it's important for us to really go in the opposite direction, as Einstein says. He says any intelligent fool can make things bigger, more complex, and more violent. It takes a touch of genius and a lot of courage to move in the opposite direction. And the word I want to underline here is the word courage. And the reason I want to emphasize courage is a lot of times when you're sitting at your work, and we will be ridiculed by our colleagues for thinking about things that are simple. And it takes courage to really stand up and say, no, I am not going to make this complex beyond what is really expected. So we are going to really work towards making this simple. And that courage is extremely important for us to be able to achieve that. So that courage is, and the touch of genius. In fact, it's really easy to make things complex. On the other hand, to make things really simple takes a lot of effort. And that's what I want to focus on today. Well, if you're sitting in a bus or a train, and if Simple was sitting next to you, would you even know that you're sitting next to simplicity? And this is something that really surprised me, because you go to almost every single developer, organization, companies, and you talk to them about simplicity, and everyone immediately will tell you, oh, we got to make things simple. The problem is not that we don't believe that we should make things simple. The problem is, honestly, we don't have a clue what really simple is. And ask them to define simplicity. That's a really fun exercise for you when you get back to work on Monday. Ask them to define what simple is. I was working with a team of developers, and I was complaining that a piece of code was complex. After me ranting for about 10 minutes, one of the developers raised his hand and he said, hey, Venkat, we really don't understand why you are saying this code is complex, because all of us collectively who have written this code think this is simple. My jaws dropped on the floor. I said, oh my goodness, you guys think this is simple? And they said, yeah, we do. And then I said, could you please explain to me why you think this code is simple when I keep complaining it's complex? And they said, well, because look at the code. All we have is simple if statements. And that's when I understood we don't know what simple really means. And I said to them, yeah, that's the problem. The problem is not that you're using if statements. The problem is that's duplicated 70 times in this function. And that function has been duplicated 20 times in your code. So every single time you have to make a change, that's expensive. That's where the complexity really comes from. So a lot of times we don't pay attention to what really complexity is. So it's really hard to solve a problem we don't even recognize in the first place. So I want to talk about simplicity, I said. But as it turns out, that's really hard. So I will kind of duck that question for a while. Maybe here's what we can do. We can work the negative logic. Maybe I'll talk about what is not simple. And maybe if we can understand what is not simple, maybe we can find ways to avoid it. So let's talk about what's not simple. Well, the very first thing is, simple is not clever. Is there anyone here who has not written clever code? Raise your hand if you've not written clever code. No, absolutely. Oh, a few of us. Have you written code? Well, everybody who writes code has written clever code. Some of us just don't want to admit it, right? But everyone has done it. Again, I talked about why we make things complex. Cleverness comes from the two. When you make a code clever, that proverbial hand comes and pats you in the back. And it says you are awesome. And it feels so much a good energy, isn't it? That's like, awesome. I wrote this code really clever. I'm awesome. Well, I'll say about my own experience with this. I was working on a project when a client sent me an email saying, we need to implement a little feature. I looked at this and said, oh, this will take 10 minutes. Why solve a problem when you can solve the mother of all problems? I don't want to solve this program. I want to solve patterns of this problem. So I took an hour and I implemented it. When I finished it, honestly, I had an out-of-body experience. Venkat got up and came and hugged me and said, you are awesome. I'm like, yeah, this is awesome. And I checked in the code and I went around with pride for a couple of weeks. Then I saw an email through the mailing list that said, something terribly has broken in production. I looked at it, I emailed them saying, oh, I've got this, I'll fix it. They said, oh, we know you'll fix it because you're that good. I said, no, I'm going to fix it not because I'm good. I'm going to fix it because I'm the one who caused it. And I realized at that point that wonderful solution, clever solution I had created had completely backfired. So what did I do? I rolled back the code, I put the 10 minutes of work into it, checked it, and never heard about it after that from them, and everything has been working. I learned my lesson really the hard way with a series of these kinds of experiences. Today, when I write a piece of code, my little brain says, oh, this is clever. I immediately delete it, and I start over again. I don't want to write clever code. I want to write clear code. That becomes really important. When we write clever code, it actually becomes more expensive in the long run to maintain the code as well. So it actually takes a lot more effort to write clear code. Let's think of a couple of things for a minute. Take a look at this one from the JDK, from Java actually. Well, what does it say? Public abstract class enum, E extends enum E. Just see, let that sink in. Oh, that noise you just heard it? That's your brain. Notice that as well. That's your brain throwing an exception at you, right? Now, this is quite clever, isn't it? It works, and I'm sure there's a reason they had to create it this way, but a lot of cleverness goes into it as well. And this happens quite a bit. When companies ask me the question, how do we obfuscate our code? I often ask them, why do you want to obfuscate your code? Your programmers naturally write self-obfuscated code. They themselves cannot understand it a week from now, so why bother really obfuscating it? So the question really is, we tend to write code that's really hard for anyone to understand. For example, I came across this code a while ago, and take a look at this little function for a minute. Now, in square root float x, I have no clue what x is. This is one thing beautiful about programmers. They will find reasons to give names that no one can understand. I mean, would you do this to your children? Would you name your child P? And they ask you, is that your initial? No, that's my full name. Well, both your parents should be programmers. I say both parents because if only one parent is a programmer, the other one will bring sanity into it. Are you crazy to name a child like this? But when both the programmers are parents, they're like, what do you want to name the child? What about P? Oh, I love it. So this is basically the problem, right? And we wouldn't want to do this to humans, but yet we name our functions and variables ridiculous names. X, I don't have a clue what that is. But here's the good news. Whatever x is, we have half of it right now. And here's x half. And then, of course, we have a beautiful double star and an ampersand, and then a beautiful shift. And don't tell me you don't understand these things, right? Because we're supposed to know all this beautiful, clever code. But here's the beauty of this code. Whatever x is, we don't know. But whatever it is, we are eventually returning it. And how do you really reason with the code like this? And in fact, remember how they told us object-oriented programming models the real world? No, it doesn't. But somebody took this to the heart. Writing a flight simulator, he wrote this code. And my question is, where was everybody at this time? Somebody should have said, dude, don't do this. And they should have stopped it. This is one of the reasons why never leave programmers alone, because they become very dangerous people. And as a result, we need to really keep an eye on it and say, no, we don't do code like this around here, and we refactor it and make it really readable. That becomes really dangerous. So it's extremely important to not get driven by this cleverness, because we often do this. We like to write code clever. In fact, to the point of insanity, we tend to really write clever code and take pride with it. That's not really a good thing. Well, the next thing I want to talk about here is simple is not necessarily familiar. Now, oftentimes I encourage programmers to ask the question, when they look at something, I ask them, is it really simple or is it familiar? And we humans tend to associate the word familiar with the word simple very incorrectly. And we need to really separate these two out and ask, is it familiar? We have seen it so many times. We are so comfortable with it. We gain the illusion of simplicity when it really is complex. We'll take a look at some examples here. So simple is not necessarily familiar. Now, I may ask the question, what does that really mean? Anyone? Yeah, well, sometimes I have audience who do speak the language, and they will quickly tell me it actually stands for simple. In fact, uncomplicated and casual and common. So common and uncomplicated. Well, of course, for a lot of us, that looks very complex, but not for people who actually know it, meaning who are familiar with it. So we have to be very careful about familiarity quite a bit. But I'm going to take a very simple problem, and maybe you can tell me if you have faced this problem before. So here is a little example. I got a list of names with me. And the list of names contains Dory, Gil, Bruce, Nemo, bunch of stuff. And then the code says, print comma separated in uppercase, names that start with 4 letters. Hey, that shouldn't be really hard, isn't it? So what am I going to do? I'm going to start with for, and I'm going to say int I equal to 0, because we know imperative style of programming. I less than names dot. Is it size? Is it length? Is it count? I'm not really sure. If it's an array, it's a length. If it's an array list or a list, it's a size. If it's another language, it's a count. Oh, in this case, it's a size. Then you stop immediately and ask the question, is it less than or equal to? Do you ever ask that question? Every single time. Somebody asked me the other day, what does the symbol mean, a new programmer? I said, that is the international symbol for confusion. Because every time we write it, we pause and ask the question, is it less than or equal to? We're never sure about it. In fact, this is frustrating, isn't it? Because you write that code and you're trying to do the boundary check in your mind. Is it this way or that way? You're walking to the bathroom. As you're walking, your colleague says, hi. You say, hi, after a delay, because your CPU is busy processing. You're having meal with your family. Your family says, is everything okay? Oh, yeah, fine. Is everything really okay? I'm fine. I'm telling you, everything is fine. Just not sure if it's less than or equal to. Well, this is really complexity. Why do we want to deal with complexity? And then, of course, it's not done. What do? If you say, all right, Venkat, that's not really true. There can be something a little simpler. Of course, we could say string name coming from what? Names. That's much simpler, isn't it? Awesome. Now what am I going to do? If name dot, again, is it length? Okay, length. And then I'm going to say that length is equal to 4. What am I going to do? Got it. That's the name I was looking for. Name dot to uppercase. Wonderful, isn't it? So when I run the code, what does it do? It printed the names in uppercase. You say, wait. Did you read the problem? It should be comma separated. Oh, of course. So I'll put a little comma to separate it. So plus a comma. There you go. You have it. And then you say, no. It's got to be on the same line. Okay, fine. It's now on the same line. Are you happy with it? Then you say, there's a stupid comma in the end. Anyone here who has seen that problem before? How did you feel when this happened to you? You didn't believe it, isn't it? You said to yourself, this cannot be happening to me. Because how do you remove that stupid comma from there? And you sit there and think about it. I could maybe put this into a string, and then I could come and strip it out after the fact. How does that feel? Really dirty. And then you say, oh, no. There is a solution. What I have to do is know that this is the last one and not print the comma. Int I equal to 0. How do you feel now? And this is only getting worse, isn't it? Because when you do this, what's going to happen? I is less than, again, names dot length. And then, of course, you're going to say I plus plus. And then size, of course. And then what do? Then you realize, how do I know it is the last element? Then you start doing something like, if I is not equal to names dot size minus 1, maybe? Right? And then you're like, I need a coffee break. This is not going to work. This is very familiar. Well, what is this called? This is called accidental complexity, right? You say, but I have colleagues who don't agree with me. That's called being in denial, right? We do this a lot. We get sucked into it. And we suffer the consequences of it. Well, the question really is, it's a simple problem, but not a simple solution. That is accidental complexity. The complexity is not in the problem. The complexity came from the solution. It is a very familiar solution, but definitely not simple. Michael Feathers once tweeted beautiful words. He said, in object-oriented programming, we encapsulate the moving parts. In functional programming, we eliminate the moving parts. Such a beautiful thought. Because in object programming, you're encapsulating the moving parts. You're hiding it. And guess what? It is still there and waiting to cause trouble for us. And on the other hand, eliminating what you don't have doesn't cause problems for you. Maybe we can work with something a little bit unfamiliar to a lot of us. Let's give it a try again. This time around, what I want to do here is to take this and say names.stream. Well, okay, I start with a stream. A stream is an internal iterator. So I'm going to start with the stream, name.stream. Then I say filter, given a name, I'm going to say name.length is equal to, in this case, a value of 4. Then I perform a map, and I say string to uppercase, convert it to an uppercase. Then what do? Collect. And what am I going to collect it into? I'm going to say joining using a comma. Where does the collect come from? It comes from the collectors utility class, and you use a joining to combine it. Notice there's no stupid comma in the end. The day that I learned about joining, I cried that night. This is like amazing. This is how programming should be, where I just get that stuff done and not fight with the language, fight with the solution. This solves a lot of my problems for whatever I need to do, so I don't have to really struggle through it. And even better, the code removes accidental complexity. I can walk through it, and I can see that in this case, I can just reason with the code. Given all the names, get me only the names which are 4 letters long, turn them into uppercase, and then join them with a comma. That becomes a lot more easier to reason as well. So let's not confuse familiar with simple. So when I work with developers, I often ask them the question, are you saying this is simple? Or are you saying this is familiar? I'm quite okay with it. It's perfectly okay to be familiar with things, but let's not confuse that with what is actually simple. And a lot of us are familiar with imperative style, but declarative style is actually simpler in a lot of different ways, and that's a transition our world is going through quite a bit, as we know. So simple has fewer moving parts, and that really helps us to reduce complexity quite a bit. So we talked about simple is not clever, simple is not necessarily familiar, simple is not over-engineered. How many times we see this? We create monsters of applications. You look at this application, you cannot even put that in your mind. There is so much. And you look at them and say, why did you guys create it this way? And they tell you this beautiful word, because it's extensible. This is the beauty. I was talking to a team when the boss came to me and said, Venkat, I need to ask you a question, he said. My team said every single day, they're creating code that's extensible. Every single day, it's a mantra. We're writing extensible code. And they put the application in production. A simple change request came through. And the team said they need a few weeks to make the change. And the boss looked at me and said, what does that mean then? I said, it's your fault. He said, what did I do wrong? I said, the code was extensible until you asked it to be extended. If you never ask for it to be extended, it'll still be extensible. And this is the myth we live with about extensibility, right? We want to make things extensible, but how do we really do it? And as an effort in it, we over-engineer things. Rube Goldberg made his name by drawing things that were overly complex as a very fun way to say how terrible we do things. In fact, school children in the US do this. My children went through this where they had to build something extremely complex. I always looked at it and said, I'm really glad your school is preparing for the real world, because we get paid to do that. You guys do it as a school project, create overly complex stuff. And we all do this, our version of this back scratcher, where this little water is being thrown at this person, and in turn, several actions happen, and then the person's back is scratched. But we all can relate to this quite a bit. I remember one of my own experiences. I was looking at a piece of code. This programmer had taken the time and effort to write it, was very proud about it. And what this code did is it took a data from the database and 250 lines of code to convert it to XML. And I'm sitting there and reading through it. I'm like, I got this finally. Here's the XML. Then I saw what happened to this XML. It went to this other function in the same application. And I'm like, that's interesting. Another 200 lines of code to parse the XML, only for it to go back into the same database. And I'm like, wow. I went to the developer and said, hey, I'm looking at this code. The data came from the database, went into XML, got parsed, and went back into the database. He said, isn't that cool? It's like, no. He said, well, I think it's cool. I said, why would it be cool? Because it's extensible. I said, extensible for what? He said, Venkat, you need to have a vision. I said, I'm sorry, what kind of vision do I not have here? In the application, where does the data come from? Here? Where does it go to? Here. Then why am I going around the world to go from here to here? No. You need to have a vision. I said, help me here. What kind of vision? The data can come from anywhere. And the data can go anywhere. And as he was saying it, I picked up my phone and I played with it. His phone rang. He said, hello. I said, hello. He said, excuse me? Yeah. Is it you, Venkat? I said, yes. Why in the world are you calling me when you're in front of me? I said, you need to have a vision. I could be anywhere in the world and talk to you. Now on, we should never talk to each other directly. We should always be talking on the phone. Well, the point is, what is the problem we are really trying to solve? We don't have a clue, and yet we want extensibility. So simple is not terse. We get confused. I want my code to be concise, but I don't want my code to be terse. What's the difference? I say a code is concise if it is short and you can understand it. A code is terse if it is short and is waiting to hurt you when you least expect. I want the code to be concise, not terse. Well, I came across a piece of code. I'm not even kidding with you. The project I was consulting on, a single license is $1 million in price. If it does something really bad, people could lose lives. And the people working on it are the top-notch trained people in the industry, extremely educated. So you can put every single quality into this project. And as I was working with them, one of the developers brought up a piece of code, and then he moved on to another file. This is code in production in the version control. And I said, excuse me, could you please go back to the other code? And he did. I said, that code, it's in production. Yeah. And I said, do you mind if I take a photo of it? He said, promise to me you will never mention our company to anyone. I said, promise I will never ever mention your company's name ever in the public. He said, okay, go take a photo. And so I did, and here's the photo I took. I'm sorry, not this line. The photo I took was the line really below this line. It said, God help me, I have no idea what this means. Can you imagine developing an industry strength application, something goes wrong, people may actually die, and this is the note. I asked him, why didn't you guys remove this quote? He said, out of respect for the programmer who wrote it. I think this was the last message of this programmer, never made it after that. But I always think about this, right? It's like you're in an adventurous trip, you put a rope and dive down through the cave, and you put your foot on the ground, and you see dry bone on the floor, and you're like, oh my goodness, somebody died here. And then you see the scripture on the wall, and you take a photo and go to some expert and say, can you decipher this? And they say, oh, this was an ancient wording. What does it say? It says help, right? That's basically what it is. I feel these developers, so when people ask me, what do you do for a living? I don't tell them I'm a programmer. I tell them I'm a software archaeologist, because I'm trying to figure out what does this code really mean. And this is crazy stuff. Why do we want to create code like this? Here's an example. If you notice, it's a very verbose piece of code. I have a test, and I have a set prices, a call to the set prices. I have a try block, and I have a catch block, and within the catch, I have an assert. Well, that's a lot of code to write. You got to make it concise. Oh, here's what JUnit 4 did, isn't it? What did JUnit 4 do? JUnit 4 said, expected is equal to, and then you have a rod cutter exception. I hate this syntax. And the reason is this is not a concise code, it's a terse piece of code. I never want a test to pass for the wrong reason. This test may pass for the wrong reason because the code that you are not really testing may actually blow up and make the test to pass. And in fact, you may ask, why did JUnit do this? It's a really funny story. The JUnit didn't do this. Remember, Java did not have annotations back then. C# had annotations from day one. They just didn't call it annotation, they called it attributes. And they had attributes from day one, and Unit, which is the unit testing tool for C#, introduced this idea. But the NUnit folks are really smart. They introduced it, and they waited until JUnit picked up. And the minute JUnit picked up, they said, this is nasty, and they deprecated it. And this is funny how you kind of wait until somebody adopts your practice, and then you say, that's a bad practice. And now they are kind of left holding to it. Of course, NUnit 5 doesn't have this problem. You can use lambdas to really work through it. You can get conciseness in this code. And you can leave the code that shouldn't be tested. So it's really important to understand the consequences of the code we write. In my code review, I never permit this syntax. Either write this one if you can, or go back and write the verbose syntax, but not the terse syntax for sure. So something we need to really think about, don't confuse terseness with concise and simple. We shouldn't really take credit in writing code that's really hard to understand, hard to maintain, once people are familiar with the ideas. As Tony Hoare says, there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other way is to make it so complicated that no obvious deficiencies. And we all tend to do this. The code is so complex, we don't even know what possibly is broken in the code. It reminds me of an experience working with a client. I found a concurrency issue, a totally unprotected variable. And I went to the team and I said, did you notice that this variable is completely unprotected? Multiple threads are accessing it. Really bad things can happen. And one of the developers got really angry and said, hey, Venkat, this code has been in production for 3 years. What makes you think you can come and scare me today? And I didn't know what to say, but I didn't have to, because another developer came to rescue really quickly. And the developer said, aha, but remember, the code crashes every week and you don't know why. And that is something we need to really think about, right? The complexity can be really hard to understand what's going on. Well, okay, I told you what's not simple, but that's not kind of fair to leave you only with what is not simple. I'll take an effort to tell maybe a few things about what is really simple. Well, the first thing I want to say is simple keeps you focused. What is the most difficult thing today? It is the focus. It is anybody's focus. If we can keep the focus, we are doing a phenomenal job. We are living in the days of distraction. Before we know it, we have spent hours responding to emails and following Twitter and Facebook. And when we are done, we are like, gosh, I still have this stuff to do. If a code can keep us really focused and engaged, that's really good. But let's say for a minute I'm working on a code. I'm not sure what function I should really call and how I could solve this particular problem. Well, remember, time is of essence. You don't want to stay in a room, dark room, for 3 days and announce that you finally figured it out when that's the first search on the search bar. So what am I going to do? I don't know how to really solve it, so I'm going to do a search for the API. Let's see how we can do the search for the API. Let's give it a try. So let's go with search. I brought up Yahoo here. I'm going to search it. And I bring up Yahoo. Oh, look at that. Sally Field's tweet on Samantha Bee's Ivanka Trump comment. Wow, that's a series of things. Is one for the books. This is funny, isn't it? This is like living the middle school all over again in our world. Who said what about what? And she said this and she said about this. And we keep fighting with each other. It's a funny world we live in. Oh, look at that. The Canadian president does not want to meet with the US president. I don't blame him, really. Interesting. NBA. You see what just happened here? I completely got hijacked. I came here to do a search. I'm no longer searching. I'm so excited to read all these fancy messages. And this is one of the problems, isn't it? A beautiful concept of yak shaving. Everyone does yak shaving. You're sitting and doing something, and you wanted to really do this search. So you bring up your browser. And what does a browser say? Would you like to upgrade? You're like, oh, of course. You click on it. Then what happens? Something went wrong, it failed. You go to your colleague and say, excuse me, my browser did not upgrade properly. Can you take a look? And the colleague says, you know what? You solve my problem, I'll solve your problem. Deal. So your colleague is on your machine, you're trying to solve their problem. You're not quite sure why that doesn't work. You go to another colleague, and then another colleague. And then in the afternoon, the boss comes to the closet, opens the closet and says, excuse me, what are you doing in the closet, alone, with this yak, shaving it? And you're like, yeah, you're right, I'm shaving this yak, but I'm not sure how I got here. And this happens a lot, isn't it? We are suddenly solving problems we never even thought of. And now you're trying to go through your chain of thought. How did I get to solving this problem? And this is a total distraction, isn't it? Let's try something a little different. Let's try Bing. So here is Bing. Beautiful. Oh, wait, look at those beautiful picture. I want to know what that picture is, but I'm a little scared to know what the picture is. It may go into a recursion. What if it shows me another picture? Let's try this one more time. Oh, this is Google. There's not a whole lot here, isn't it? How many of us use Google for searching? There's a reason for it, right? Because we value our time. When you go to Google, it says, what do you want to do? I came here to search. Well, then damn search. There's nothing else I can give you. What if I want other things? Well, then search for it. Now, let's not make any mistake. Just imagine the day when this screen was implemented. Was it an easy day at work? Can you imagine? You go to your boss and say, you know what? That little view you want me to implement, I'm done. Show it to me. There you go. And the boss looks and says, really? Where is everything else? What everything else? I'm done. I don't get it. Oh, I know you were going to say it. That's why I implemented, I'm feeling lucky. Well, you should feel lucky, right? How many of us will have the courage to stand up to this? Honest question to ask ourselves, right? How many of us will have the courage to say, that's it? Let's make no mistake. You click that button, there is huge amount of complexity behind that button. But they thought of us, the users, and said, I want to keep your focus. I want to know why you came here and deliver what you came here for. And not waste your time giving you stuff you didn't come here for. That is a touch of genius, isn't it? So the point really here is that perfection is achieved not when there is nothing more to add, but when there is nothing left to take away. Brilliant quote, isn't it? And I always, this is what refactoring for me is. This is what editing books for me is. This is what writing code for me is. If you ask me, what do you do for a living, Venkat? I work with clients, and when I leave their campus, they have less code today than they did when I went in. Because I am not in the coding business. I'm in the code removing business. Because way too complexity unnecessarily brought into applications, time and again, over and over. And it's not that they're not smart enough to see it. They're extremely smart. That's a problem. And they're way too close to the problem than I am. This is what I always say. You know, what's the difference between an employee and a consultant? The difference between an employee and a consultant is the difference between a parent and a grandparent. As a parent, it's your child. As a grandparent, you borrow the kid and you return it at the end of the day. I love being a consultant because I'm not emotionally attached to it. I can go in and I can look after their little kid and I can return it back at the end of the day and say, here's my advice, take it or leave it. And that's the whole point is, and a lot of them do. And they remove a lot of code because that adds to complexity. So simple eliminates accidental complexity and hides inherent complexity. So that is exactly our job, is to really understand, discern between accidental complexity and inherent complexity. Where does accidental complexity come from? Accidental complexity comes from, sadly, the solutions that we use. The problem has complexity. That's inherent complexity of the problem. The banking industry has its own problems. The travel industry has its problem. Medical industry has its problems. That is inherent complexity. The solution we bring to the table, unfortunately, brings complexity. That is accidental complexity. And what do we do to deal with that accidental complexity? We bring more solutions in. And what do those solutions do? They bring their own complexity, and quickly we get sucked into this vicious cycle of complexity that we have to deal with. Well, the next thing is, simple keeps our focus. Simple fails less. It's not that things are not going to fail, but simple fails a lot less. And this is one of the things we should really try to do, is to make our systems more robust and fail gracefully as much as possible. I'm sure you've all heard this question. Why is the cover of the manhole a circle? And I'm sure everyone has been asked this question at some point in a real interview or a fictitious interview. And of course, we all know the answer, isn't it? The answer is, it doesn't fall in. Well, that's only half the story. There's always other details. Imagine this for a minute. If you put a request for proposal, and your request for proposal says, dear company, design something that does not fall in. How many of us will design that? Very few. You can charge more money if you design something else. And it turns out each one of those won't fall in as well. Because of the shape. If the shape is any one of these, you won't fall in. And if you're designing something really fancy, you can charge maybe more money designing one of those. But there's one other benefit this one offers compared to the other ones. And that is, it doesn't matter how you roll that over. Imagine you are the one coming out of that hole after a very long day, and all your colleagues are waiting, and you're like, let me figure out which direction to put it. Roll the damn thing over, let's go home. What a wonderful thing. So it's really easy, it fails less. Not only does it fall in, it fits in every little direction. You know, call me silly, it's been a while now, but when my children were really, really young, and I say this is the corrupted mind of a programmer. I cannot think of anything but programming. When my wife said, could you please go get that bottle to feed the child? And I'm like sleepy, walk over. I take 2 bottles, I'm trying to put the lid, and I stop and say, this is awesome. How beautifully compatible the lids are from different manufacturers. I wish my software was like this. While she's like, are you done yet? Oh, yes, of course. But the point really is, this is truly what we are trying to do, is compatibility and how we can really fail very less, right? Failing less is a really good thing. Robustness is a really good thing. Well, simple is easier to understand, and simple is easier to work with. And again, this was a day when I had not slept through the night. Legally, I shouldn't be driving that morning. I was so tired, I could barely keep my eyes open. And I had worked all through the night coding away. I said, I'm going to go home, grab breakfast, and come back to work. I'm driving home, and I was so sleepy, but I'm running out of gas. So I pull up to the gas station, and I pull the gas nozzle out, and I'm trying to fill the gas. It wouldn't work. And I'm like, Venkat, think you're too sleepy, what's going on? But I couldn't fit in. And I said, okay, let me just think about this. And I clear my face, and I look at it, and I was so thankful, because you may try this sometime if you want to. The diesel nozzles are very different in shape compared to the gasoline nozzles. I was so thankful, because I would have lost my car that day had it not been. And I really thank people who design sensibly like that, so we can actually fail less. It's easier to understand, easier to work with. Well, as a point here, well, we know what a prime number is, and I wanted to really experiment with this. Is divisible tells us whether something is divisible. Is prime says number is greater than 1, and then give me divisibility. Okay, is prime tells us if a number is prime. But look at this one, primes at starting. If is prime starting, then return concatenation of starting and all the primes that follow it. Otherwise, just skip it and return everything that follows it. Well, really easy to write code. Only one problem with this code: it doesn't work. It's going to fail with Stack Overflow error, isn't it? Because the call stack is going to go and run through the roof. So this was something that I got really excited about. And so I wanted to solve this problem. I was writing a book on Java 8. And as I was writing the book on Java 8, I said to myself, wouldn't it be nice if we can solve this problem elegantly? So here's what I did. I said stream.iterate next prime, sample colon next prime, limit count, collect. But how do I really make this work really if I want to get this implemented? Well, notice the next prime method right here. How do I really get that to loop through and get the values through? Well, simple is really elegant. We want to be able to do something like this. How do we achieve that elegance? Well, I'll come back to that in just a minute. Well, there's a reason why we all admire this one. If you really think about it, this is simple, this is elegant. What is there in this picture? That is the beauty, isn't it? No clutter, no distractions, no unnecessary ornaments. The simplicity is the beauty is the simplicity. And this brings back memory to something that I had done, and I call this the architect dilemma. And this is something we need to really think about. And that is, when it comes to designing, I was walking through the downtown Boston, and I came across the Trinity Church. And I just stood there mesmerized. I could not move for so long until my family said, move now or I'm going to call the cops. And why was I so excited about it? The reason I was excited about it is a story. Actually, I was not looking at the church. I'll tell you that in just a second. This is a beautiful church. It's been there for a while. But next to this church, a company wanted to build a high rise, a John Hancock building. And the government would not give permission. They said, no, we're not going to permit you to build something here, because if you do, the beauty of the church will come down. The architect challenged the government and said, I will build it here, and when I am done, without touching the church, the beauty of the church will only be better than it is right now. And here's what he did. He placed the building in an angle. Even more than the church, the reflection of the church is amazing. I stood there for the longest time staring at the reflection and not the church itself. And I was like, wow, this is amazing architecture. And my camera doesn't do a really good justice to it, but if you ever get a chance to go to downtown Boston again, walk through and look at this building, it's just amazingly beautiful. And I thought to myself, I said, I'm curious, I want to learn about this. That's when I went and started digging through it, and I found more details about it. And that's a beautiful solution. It turns out simplicity has to really evolve. And to make that point, I'll give you an example. Richard Feynman says, if you cannot explain something to a first-year student, you haven't really understood it. And this is one of the things, when you describe things, if something is overly complex, a sign of that is it's really hard for us to explain to somebody else, and we can know that this is really complex from that point of view. Or Occam's razor says, if you have two equally likely solutions to a problem, choose the simplest one. So like I mentioned, I was writing the Java 8 book. And when I was writing the Java 8 book, I typically write books over a 2-week period. I don't have time to write books. I travel almost continuously. So generally, as Mozart, I think, said, everything has been written in my mind, I just have to put it on paper. It's the same thing that I do. I spend about 2 years thinking about a book I want to write, and then I kind of close my door and window, and I lock the door for 2 weeks. My kind family literally slides food under the door for 2 weeks. And when I come out, I have a book written with a lot of beard on my face. But the point really is, I sat down to write this book on Java 8, and I was in this 2-week journey to finish this book. But as I was writing it, I really wanted to, right in the middle of the book, show how we can do tail call optimization. And not a good thing to try something new like that in the middle of a book. But this was about 2 years before Java 8 was released. I was writing the book while Java 8 was being written as well. And in this case, I wrote the factorial. Well, not a big deal. That's going to fail with the Stack Overflow. But I've read books like, for example, books like Structure and Interpretation of Computer Programs. I've programmed in languages like Scala, Clojure, and Groovy. Every one of these languages has tail call optimization, though done very differently. Scala does it at the compiler level. Groovy, on the other hand, does it at the library level. And Clojure also does it at the compiler level. But I was like, wow, what if I can do something like this in Java? Well, we know that Java doesn't have tail call optimization, but I really wanted to do it. So with the strength of this book and the strength of these languages, I started playing with it. And so what I did was I created a tail call function, a factorial, returning tail call. And if you really go a little deeper into it, I put 2 days of effort, and I then spent 10 hours refactoring the code, and I came up with something like this. It said invoke, and then the invoke method says is completed, call complete. Then it says while not call complete, loop through, call the apply, get the current.isComplete, set it. I wrote this code, and when I finished it, I knew I was in trouble. The problem is, if you look at this code, notice this line of code, current equals current.apply. What is that? Well, that's mutability. Well, in the book, until the previous page, I kept telling the reader, avoid mutability, avoid mutability, avoid mutability. And what am I doing here? Mutability. And I just sat there and stared at it. And I did not, for the life of me, know how to get rid of mutability. Then I came up with a brilliant solution. I think this was really brilliant. And my solution was to put a little footnote. And the footnote said, dear reader, do you notice I'm using mutability on that line? Turning this code into immutable is left as an exercise to the reader. This would have worked really well 30 years ago, when authors could write books and hide behind and never have to see the public. But in today's world of Facebook and Twitter, the next thing you're going to know is like, oh, really? Why don't you show us now? That's not going to work. Then I played with it for another day. Still couldn't figure out. And then I came up with the second best solution. I said, do you notice I'm using mutability? Well, don't use mutability except cases when you cannot avoid it. And I'm like, gosh, that sucks. And then I came to this wonderful conclusion. And that conclusion was, my code simply sucks. And I said, maybe I won't write about it. Maybe I don't have a clue. Maybe I'll run into smarter developers. I will ask for help. And I put it away, and I started doing other things and writing the rest of the book. Then a few days later, I was on the treadmill, far away from the problem. And as I was jogging, slowly in the back of my mind, I'm thinking about this problem. There's another thread, constantly thinking about it. And suddenly it dawned on me, oh my goodness, how did I not think about it? And I realized that Java now has infinite streams, unbounded streams. And it occurred to me right at that moment, oh my goodness, I can use infinite stream to solve this problem. And the minute that thought came to my mind, I jumped out of the treadmill, run across the 2 floors of my house with my children screaming, are you okay, Daddy? I'm like, I got it. 15 minutes later, I had the solution on my hand. So what I did was I said to myself, stream.iterate, this tail call apply, and then filter on is complete and find first and get the result, knowing that tail call optimization will work here because it's an infinite stream, and infinite streams apply lazy evaluation. So the trick was to use laziness to implement, tail call optimization. And eventually, that's the solution that actually went into the book as well. But that was an aha moment, something that actually was so elegant and easy to write, but was so hard to really think about to begin with. And I realized everything should be made simple as possible, but not simpler, as Einstein said. But then I look at the code, and I always ask the question. When I write code, I ask other people to look at it, and they look at the code, and sometimes they say, gosh, you can make it simpler. Well, I thought I had made it simpler, but they want me to make it really simpler moving forward. And that really makes me wonder, is my code really simple? Or I just assume that it's actually simple? And I don't know the answer for it, but it really doesn't matter, because every single day we have to make our efforts to make it simple. And in a way, I would argue that simplicity is Schrodinger's cat. Maybe the code is simple until somebody shows that it can be simpler. And I think one of the most important things for us developers is to have that open mind, for somebody to come and challenge us and say, hey, you know what, good job, but by the way, you can actually make this a lot more simpler. And if they tell me that I can make it simpler, that is actually strength to me, because I'm learning something I didn't know before. And the next time I sit down to solve a problem, I can start from a different level than I did already. So that is to our advantage as well. But simple is something we have to take the time to evolve. This is one of the problems we run into a lot of times. We write the code once and we say we are done. Well, it's far from it. The first time we write the code is just the beginning. We have to rewrite the code, refactor it, and simplify it. And just knowing that the code can be simpler gives us the courage to go back and play with it and maybe make it simpler, and that is worth it. And simple makes things really easy, but unfortunately, it certainly is not easy to make things simple. So while simple can make things easy, it's never easy to make things simple. And that is something we have to really work hard to move in that direction. But as Da Vinci said, simplicity is the ultimate sophistication in life, and every effort we put in to do that is worth it. And the fight we've put up to make it really simple can really help us to elevate our strength, so that the next time we face a problem, we are armed with something bigger and stronger to really attack that. And this is something we continuously learn and get better. So to me, every effort, every hour, every minute we put in to make things simple is something that is not just useful for the problem at hand, but it's useful for our career in general. Hope that was useful. Thank you.
Any question, guys, for Venkat? Okay. So thanks a lot for being with us on the first day. I hope you enjoyed all the talks and the sessions. See you tomorrow. That's all. Thank you very much, Venkat, again.
Thank you.
Se la